Whoa. It is time. It is time. Time to be serious. Time to be serious. Time to be serious. All right. So I'm going to keep I'm going to stick to 2D. There's some old code that I wrote a while ago. I wonder if I still have it. Because I know I got rid of it. Can't even do the blade because it's just not going to be there. So I got rid of polygon code there, which means just before that, it should be here. Oh, in fact, this is where I put it in. So basically the same thing. This is the polygon. I find the best point. Split in polygon, I go through each segment, get the closest point. If it's there, then I use it. And then it was also still just kind of dead code too, because yeah, I don't even think best mass center is used at all. But I can bring it back. Because at the very least I need this to prevent like rotation. This should just stop rotation from happening. At least it should really help reduce it. There's also sort of there is sort of a problem where a leg can only go up to whatever the body mass, whatever the leg mass ratio is, over its normal power. So what I'm doing is I'm having, in the case where I have like one leg on this side, two legs on this side, these two legs would do less, and this leg would do more. That leg can do up to double if I have a leg mass ratio of 0.5. So I need to figure out whatever that factor is, however much higher it can go. Clamp that, and then the other legs will have to, I mean, yeah, I think I just clamp it. I don't think I go look at the legs and say, all right, you were doing this much, but I was only if this one could do this much, now you need to do, this one is doing less, so now you need to do less. I don't want to do that. Everyone's still going to do the best they can do, but, you know, clip to a certain point. Yeah. So leg polygon. Like polygon clear, I get the body plane. Oh, I think, yeah, I'm just projecting it all onto the body plane. Which then makes the center of mass just be the 0 coordinate. If every leg is, yeah. Oh, and then I build the polygon there. I project the leg ground point onto the body plane, and then I get its offset to the center of mass as the origin point. Turns from origin plus the center of mass. Yeah, okay. Yep, okay. It does possibly have some issues where, because I treat it as two-dimensional. I mean, it's the gravity, it's a gravity force, right? It really doesn't matter where it actually is in 3D space, because the problem happens when we're like this, and now the gravity force is actually applying rotation to the body. So it doesn't matter if the leg is here or if the leg is here and the leg is here, as long as I flatten it and I'm like matching that. The idea is just to kill rotation there. Right. But also to apply anti-gravity. But to do it smartly so that we're not rotating. I just hope that it works. I just hope that it works. Okay. Alright, well, let me start with this. Like polygon. Ground leg center point. I'm not really sure how that's used. It doesn't look like it's used. It's not. Okay. And yep, then I'm like sorting it in order. I'm building the polygon in a good order. So on the iteration, just before we start the first leg, Dog, there's no way. I actually seriously just took you out. I swear. I did. I actually really did. Dog. Okay, well, I gotta take the dog out. Okay, maybe I didn't. No, I did, because I took a shower, I took him out, I got coffee, and I came back here. Dude. Okay, I'll be back. Not back. I'll call this not really the body plane. Well, no, I should. I don't know. What do I call it? Attachment plane. I leave it as attachment plane at least. See, I'll just bring the body plane back. Okay. And then I have this code. So plane point is a body plane, projectile like ground point. Oh, right. Then I have to move it back. That's right. Wait, should it be leg ground point? Because this is global. Shouldn't it be this minus that, and then I project it? No, because body plane is global. Wait, I'm so confused. I know this was correct. But why does it look weird? Why do I think it's wrong now? The plane has the same direction as that, with this body's center of mass being on the plane. And then plane point. Take the leg ground plane, which is in global space, onto this plane, which is also in global space. And then okay, and then I move it to the origin, essentially. Right. So basically move it to the origin, and the origin is now the center of mass, effectively. Okay. So now the plane point. Yeah, okay. So as that plane move to the origin. With this effectively becoming the origin point. Okay. And because it is on this plane, on the Y plane, I can easily extract the X and Z coordinates. Right? And then the center of mass I know is this, just the origin point. So if it is there, then that is the point that I target. If it is not there, then I'm targeting whatever this is, the best mass center, I suppose. So do that right after they like displacement. Okay. And then my code, when I have this translation, what I do is essentially I take my target point, wherever that is, and I subtract that from all my points. So this would normally be like -0, right? For the origin if it's center of mass, otherwise it's shifting it by this mass center. which is now inside the polygon. Or really it's going to be a point on the segment. I don't think I have to cap it. I know there is part of this method that has like a capped version of it. Oh no, uncapped. The default is capped. Whoa, where am I going? I don't know where I'm going. Okay. So now I have that, and just to be sure that I've done it right, I'm gonna bring this debug back. Yeah, okay. I'll just do it up here. And then I may bring back the debug like polygon. Like mass vector? I'm just gonna drop that for now. I don't know what I'm gonna do with that. Okay. Let's see if this works right now. I'm on index 4. What? What? Okay, right, so it is different. Okay. Why that like not lift? Alright, cool. Looks like that's working. Size is less than or equal to 0. That's not possible. That's not possible. What? That doesn't make any sense. I thought clamp was supposed to fix that. Okay, this dog's trolling me. You're alright. Nope. Nope. You're okay. You're okay. No. Go lay down. You're okay. No. Okay. Got that. Best mass center. So this is my target point. Okay. This. I'm pretty sure he's hearing me say okay when I unmute, and he thinks that that's me telling him I'm going to. Alright, best mass center. So I take this. Right, so the plan is the logic is I have my points. I need wait, what do I do with the target point here? I don't even use it. Okay. Yeah, so I just have the points, which should be near the origin. If this is some value, then I need to offset those. So I need the original points. I need. I think what I'm doing is I essentially take the final length of the vector to each point over the initial vector's length, and this is my gravity multiplier effect. Because the whole time I keep all the lengths the same, so if I reduce some, I increase the other one by that same amount. Yeah. Right. But because they move, they do change a little bit. And then I think like 5 iterations is probably more than enough in this case, because it is always over a small period of time. I mean, it's happening constantly, so like errors can build up, but something is a lot better than nothing. So yeah, what I'll do is I'll just kind of write it as a function. So I give it in an array of leg points, and I receive an array of multipliers, basically. So this is the polygon as well, which is translated to the origin. Because when I display it, I have to translate it back. You have to do state transform multiply by these, yeah. Okay. All right. So I can say calculate like gravity power. I give the leg polygon, and I give best mass center. So from these two things, I obtain this list, and this list should just be in effectively in index order. And I just increment it every time I get to a leg. They are still going to be by... I think at this point now I can do shared mass. And since this one is kind of a big thing, I cannot do that. Right. And this one's just gonna be... I don't think I limit this one here. I don't limit it when I calculate it, but when I send it out. I make sure that it's between 0 and whatever the maximum amount of force I can apply is. Which I think shared mass already accounts for that. Yeah, shared mass already accounts for that. So I don't have to do... Shared mass already accounts for that. So does that mean these vectors can't go over 1 then? I need like a maximum, I think. Because I do need to have shared mass could be lower, but it could be a shared mass could be lower than the max, I guess. So what is the max? The smaller value between this value and the smaller value between this one and this other value. I guess this is supposed to be the maximum that a single leg can apply. Maybe I say this. Because if I say 0.25 is the leg mass ratio, 0.25 means I need to have 25% of the legs to lift the entire body. Which means this would be mass over leg size times 1 minus 0.25 times 0.75. So the maximum mass a single leg can lift is that value. This seems to make more sense to me. Okay. If 0 procs, max leg mass is just the mass of the body. And that just essentially means one leg can lift the whole body. Otherwise, the max leg mass is the mass divided by so with 6 legs, it would be 6. Let's say the value of the body leg mass ratio is 2/3. So 1 minus 2/3 is 1/3. So 6 times 1/3 is 2. Mass over 2. The max leg mass is half the weight. So with 2 legs, you could lift the full body. Does that make sense? Number of legs needed to lift the body. I said 2/3. Leg size times a third. 6 times a third is 2. Mass over 2. The max leg mass. Yeah, it doesn't seem right. Okay, I'm gonna plot this, I guess. Because apparently I don't know how to do math. Yeah, that's obviously wrong. So if I need 2/3 of the legs, then I need to have 4 legs. 6 times 2/3 is 4. My mass is 100. Yeah, so this is actually correct. So it should just be this times R. I don't know how I messed that up. Right, okay. So I only need 1/4 of the legs, which means this can drop until a 1/4 of 6. What's a quarter? Okay, I don't know what a 1/4 of 6 is apparently. 8. 2 is a 1/4 of 8. So I can have the whole body with 50. Spend a third. I can lift with 2. If I need a 1/4. If I need a 1/6. I can lift with 1. Which means I can always lift as long as I have 1 leg grounded. Mass over legs times the ratio. Share is the smaller value between the mass over grounded and that. Which this is actually a little bit different because this is more grounded leg count needs to be applied ground forces. Grounded leg count. Where's the leg ratio used? Never. At the very bottom. Right, okay. Assignment not allowed in an expression. Oh right, it's gonna be so I'm gonna take, yeah, I'm just basically gonna do it again. I can multiply it up to whatever would be the max leg mass that this leg is applying. But also being sure that I don't make it negative so I don't apply more gravity or something. Because I'm expecting there's like probably some edge cases where a value, a vector could possibly get really close to 0 or even flip and be negative. Though I'm sure it's really unlikely. But if it does happen, it would be non-physical, and then a lot of stupid stuff would happen. So I need to make sure that just doesn't happen. A single take of that would just be, could be really bad. As with anything in physics, programming, mistakes tend to compound and be very obvious very quickly. It could be the case that applying more gravity makes it worse. And then it continues to apply even more gravity. I do want to avoid the array copies. I suppose what I could do No, I mean, that's not really much better. I was gonna say I could just like have 2 arrays and just flip them around whenever I find a better one. Because it's possible I can do an iteration and end up worse. That's always a possibility. So if I ever do an iteration and I get worse, I mean that happens when I converge, which could happen. So if I do a flip, or if I do a calculation and it's worse, then I need to return the previous calculation and not the one that I just did. Which means I need to save both. At some point I have to save both. So it's unavoidable, really. Alright, first thing, shift everything by the target point. These are always passed by reference, so I will take a copy. I can also just provide the copy. I'll just take a copy myself. Yeah, I'm just gonna take a copy myself. But I think I do have to track the original points though, right? Because iterate does this, where it has a working result, an original value, so I can maintain directions, direction projections. Though if I do end up with a zero point, I do have to ignore it. I can't use it. Well, actually, here's the thing about a 0 point. It kind of is like a free dump for length, because 10. Yeah, wow, here's it. Okay. So, that is a conundrum actually. If I have a leg directly beneath the body, I can just say, all right, apply anti-gravity to that leg, just full anti-gravity, and then I pay attention to the other legs and try to balance those ones. Maybe that is what I do. Maybe I check that. Maybe I look and say before I do any submission to this and say, or I guess I just ignore it, actually. I might just ignore it and just leave it at 1. Yeah, because if it's... No. Wow, hang on. This is weird. This is weird. Hi, Yulia. I just had a thought. What if my thinking on making it so they all sum up to like being at the center of mass is wrong? What if it's more that they all need to sum up to being at the gravity vector? How's life? It's good. How about you? Yeah, I think it's probably different. Because if I imagine the gravity vector being a vector from the center of mass pointing down, I'll just flip it around just to make it. Oh no, yeah, I point it down, right? And then I draw the vector to each leg. I need to make it so when I add up all those vectors, they're sitting on top of that gravity, where that gravity is at. Fixing the in-game recorder to be less crappy. In-game recorder? What does that mean? Does your game have a camera? Does your game have a camera that you film with? I don't know how to say that. That just sounds strange. The recorder I used. When you say in-game recorder, do you mean like it's part of your game? Like there's a button in your game that says record? Or using a different software? I think this is right too, because this solves that 3D issue which I just had, was legs being at weird offsets. Yeah, I think that's what I need to do. I'm going back to 3D. Am I going back to 3D? Yeah, because I'm stupid. Focus lock-in. Yeah, my task text. Focus M. But I didn't want to do 3D because I was seeing that it was just... whatever the pattern is there, it's got to contain like some kind of irrational value. Or it's just something so complicated I can't see it. I feel really tired too. Alright, I need to flip up the music. Let's try this. The problem with that too is that it takes a long time to converge as well. Like 50 iterations, the best constant I can give, and it doesn't reach it. Like 50 iterations and it goes from like 2 meters to 7 centimeters. Which for me is not enough. In 2 dimensions, I can get from like 3 meters to precision in 20 to 30. Like floating point error range. Like I'm literally as good as a computer can get. With the limitations of floating point math. But how do I fix that? I guess the question is, my points are in 2D space, which is probably fine. But my lengths... My lengths... Oh, jeez. Okay, let me... I like that a lot, though. Alright. Let me do this. I'm gonna go back to testing this. I'm gonna go to 3D. I'm gonna test... between 1 and 8 points. I'll do 100 tests. I'll run 30 iterations each. Okay, I can go like 100 iterations if I'm doing that few tests. Generate points, 3 dimensions. Negative 2 to 0.5, that's fine. The target point though, I'm gonna do this. The target point is going to be think about this. So the gravity is essentially 9.8 meters per second down. It's a vector pointing straight down 9.8 meters per second. So I could just say it's at 0, 0, negative 9.8 down. Each leg, I will say, has just an initial... If I treat these as legs, which maybe I should just construct it in a better way. So instead of doing generate points, well, no, I can still generate the points. Did I see one that was like, it was like 0.48. It looks like a third is probably good enough for 6 points. I could just make it contrived. Alright, let me make this like a function here. I should just be able to put this and paste here. And just rename these. Count dimension. I guess I need the dimensions. This is just so I don't have to delete this code. I can keep it around, but I can just also get out of the way. And just not run it. Dimensions, min point, max point, test, max iterations. Okay. I'm just gonna double check that this still is definitely functional. Test is not. Did you mean print? No, I did not. Points. What is points? Huh? How? How does that work? Line 42. Wait, what? Oh, line 42. How did I have points written here? How would... Division by 0. What? Testing 1 point? Oh yeah, I guess that's... I mean, I guess that actually... It does... Whatever I do does have to handle that case. So how is that being strange, though? Iterate... Zero, total, count, 1. I don't know. -1. Okay. Is it spinning forever right now? Oh wait, no. Yeah, why is it, just... How did I break it that badly? I'm actually quite... I'm super confused. All I did was I moved code around. Why is it suddenly like the buggiest thing I've ever written? There's like there's basically just 2 syntax errors. Why is it doing this? It's like literally not doing anything. Also, this code is still weird to me. How does this... Points. What is points? How was this working before? Like, points is not defined. Right? I'm getting points. I got 5 points. Really? Okay. What are these, like, weird, randomly scientific values that's printing sometimes? It's so strange. I'm actually super confused. Okay. So testing 3 points. The first thing is an array. Huh? Why is the test set printing so strange? I see 4 points. Oh, because that's the 4 point. 3 points, the target. The length. Closing. Okay. What I do know is I don't need the target, though. Target's actually just not necessary at all. Okay. Get down on. Iterate. Test sets look good. Okay. Can what the hell is going on? I'm trying. Oh, right. I changed this. I guess I don't need to do it that way. I'm just grabbing the last iteration that was successful. Okay. This is such a mess, it really is. Display? No. Please stop. What the hell is happening? Why is that still printing? Okay. Interesting set of numbers here. Very interesting set of numbers here. Okay. Well, run test works now, so I just want to do that. So I'm going to do it differently. I guess what I do is I take... Well, I'm just going to cut all this out. But I guess I'll leave the test there though. But I'm doing 3D. So we should do a new method. I'm gonna say something. Dude, what? I'm going to name it I'll just call it test gravity. It's going to accept, I guess, nothing really. I'm just going to run all the code from here and then just call the method. Okay. So I want to go from one leg, I can honestly just like totally ignore it, really. 2 legs is where I can actually start possibly doing something. What are you making now? I've just got to really solve this gravity problem. I think I might be onto like the real thing. Is this looping? I feel like. I don't know. I just don't. Whatever. The playlist definitely hasn't looped yet. I feel like I just started it. Yeah, definitely just started it. So I need to have a test data is going to be the I mean, I can just prepare something. And actually, hang on. The location that I'm applying the force is where the vector should be going, which is the spring midpoint. This is the polygon. I'm using the polygon to get... No, this is the polygon. Because this is where I'm applying the force to. Yeah, I should be taking the spring midpoint. The like ground point. The spring midpoint is relative to that already. I take the vector from... Wait, why is it plus? Huh? Like ground points in global space, global attachments in global space. Why do I add those two together? Oh, I'm getting the... That's what I... Yeah. I'm getting the midpoint. Okay. So this is the midpoint in global space. So this is relative to the origin point. But then I need it back in the global space because that's in the body plane. I mean, I think what I do is I still generate... I think I still generate the points like that, but then I take the target point and I just move that target point down. The leg length, I need to somehow... to the midpoint. The number, dimensions, and then the range. If there's going to be the midpoints... Okay. I'll format it like that. So then I remap my midpoints to that target point. And I guess if I treat everything as one, right? Like I have a mass of one. All right, I need to have something in here like body mass, so I'll just say like 64. Right. So I think what I do is I take that target point, I scale it to 9.8, and then I scale it to the mass. So this is the amount of force I need to do. And then each of those legs, the midpoints, I'm trying to get a visualization in my head for this, what this means. What does the direction mean? The direction from the center of mass to that. I think it's still the same visualization, it's just now in 3D. Where if I have the triangle, these two are going to pull that. The resulting force vector is going to be like centered over here. So this one gets more power and these ones get less power so that it's centered with the center of mass. Looking at it from the side profile, I have a leg here and two legs going like this. So if I would add those together, I'd go here, then here, then here. Right? So the result will still be the same. Essentially, the leg on this side and one of the other legs would cancel out, so they'd be center. But then top down, it'd be like above or below. And the other one cancels that thing out, so now it's like center in the same base plane. But now this point is way over here, which means this point I have to get longer to drag it back. And those two would just have to shorten in equal amounts so that the total length of the whole thing is maintained. And then I think what I do is I have... Yeah, but the real question is, what are the lengths of those vectors? Okay, let me imagine I have two legs. Yet the direction's just kind of like weird though. Because if I have the points like way out here, that's just like canceling out the direction. If they both apply a force straight up. Right, they're not applying it into the body, they're applying it straight up against gravity. So it's more like I add those two together and I get their position. But when I'm trying to align it, I don't really care how far down I go. I only care about getting it centered on like a flat plane. Because let's say I have a leg dead center. What would I do for the first iteration? I would... maybe what I do is I bring back that third dimension, but that third value is the length of the vector. So a vector of 3 components, the x and the z, or I guess if I'm in 2 dimensions, it's the x and the y, and then I have this third value, which is just the length. Dang, this one is tough for me to see. I'm not seeing it. Right. So this is the body plane. Then I would have... Can I really not, like, set... Why can't I say, like, Hey, when I draw this line, put an arrow at the end. Why can't I say that? Where's that option? It's here, but then I don't get it here. Whatever. Why is that way? Why is that literally on the other screen? Okay, now it's back. Okay, right. So now I think I see it. Just setting it up. Okay. So this is basically what this looks like, and then here's my imagining for, or here's what I imagine for the gravity vector. So it's just a vector that just points all the way down. The length of this one, it's at the center of mass, so it's at the origin, and then it just points straight down. And because these are all basically from the same place, why is this like just totally different snapping than the rest of these? Whatever. Right. Did I just move this whole thing down? What just happened? Okay. So the length of these vectors in their original form matters in the sense that it determines where it determines like what scaling it will do to the result. So if I were to scale this, it just goes right, it expands in like a straight line here. But it kind of determines like, if I had a vector like this, a small increase in scale gives like a big left to right change, right? When it's like this, a small increase in scale gives an even smaller change in left to rightness, right? So what happens is when I stack these up, I end up with a vector like that's pointing way over here. So I take this point and I essentially just bring it all the way back up to the top. And then each one of these would essentially have like a value of like a power of 1, right? And the total sum of that power needs to be the same. Yeah, okay. So I start with, okay, So I actually have a 4-dimensional vector. It's in 3 dimensions. This is just flattened projection, but it'll be in 3 dimensions, so it encodes like a proper direction. But then I have this 4th value, which is always, it just starts at 1 for every vector. And that's my rescaling. That's like a scaling parameter. So, what do I do then? I end up with this last point, and I would essentially just look from the top down and say, how close am I to this point? So I flatten it out so it's just on this plane. So let me visualize that. It comes back up here. So I flatten it. And now I have my offset, I guess. So now how do I deal with this? I guess what I can do then is I can look at I can just do the same thing. I just project it back to 2 dimensions, and I project even my vectors back to 2 dimensions, and I say, all right, I'm going to have this translation, I guess. Maybe that's just what I do. I take every one of these vectors, and then I effectively translate them like this, I guess, such that they are, you know, about halfway closer or whatever it was for 2 dimensions. And then I project them back onto the original ones. So then they would essentially rescale at that point. And after they rescale, that's probably when I look at that second that 4th component, and I say, all right, what did I do for this? And I guess in this case I can just keep it simple and just treat the y-axis as the up, so they're oriented in the same way. So it's always pointing down. Actually, now I'm worried. Does that really work? Because it is different when they are like lateral, right? Like what happens when the gravity vector is essentially whatever surface we're on. Gravity vector is now like over here. What does that mean? What does that mean? What would this imply with this setup? It would mean the crawler sideways, 1 leg over here, 2 legs over here. Which, in order to get over there, there's only really one solution, is just to minimize this vector and then increase these ones. Focusing on this, on one of the legs that's, I guess, more aligned in that direction of gravity, too. But when it applies, yeah, when it applies, what's actually going to happen is that, yeah, so that's, okay. Now I get it. So gravity vector does always point down in local space. Because what it means is that that vector essentially projects back up to the center of mass, because that's what we're comparing it to. I mean, it's probably just a bad idea to even represent this as a vector like that. Yeah, that's just nonsense to represent it that way. It should just be like that. It's just a point. I want to get these as close to that point as possible. And I think if I understand what projection means, I can essentially look at a vector face on. Like if I were to say project this vector onto this green vector, what would I see? I think in my mind it just makes sense that I am essentially just doing this. So the vector does get shorter, but it aligns with that one, right? The reason I say that is what happens in the case where, this is one of the reasons I was thinking about doing this way, is to fix the case where I have a leg that is just perfectly aligned with the center of mass already. Which means I just want it to apply, probably just never change. Which means during the shifting phase, what happens? What happens during the shift phase? Why is it being like kind of weird like this? In the shifting phase, this would happen. It would move over like this. Its length would increase because of how I apply the shift. But then I would project it back onto itself. So essentially the vector would just remain unchanged every time I do anything to it. So it still has that one length value, then I would compare its current length to its reprojected length and say, oh, I didn't change this one. So I just leave, that value stays at 1. But what happens during normalization? The length of every vector of the other vectors could have increased, which means this vector length would decrease. Which doesn't really make sense. It shouldn't do that. This one should always stay unaffected. Well, I guess not necessarily. The other ones could steal length from this one for balance purposes. No, that really wouldn't make any sense. Can I do more than one of these at a time? Oh, I can. Cool. Alright, so let's imagine this. The projection would do something like this, right? It would go way over here. In fact, let me duplicate. So everything would shift over. Why did I not grab that one? So everything would shift over, and then we would reproject. For this one, can I not have them select anymore, please? Thank you. This one just moves back. This one, spin. Okay, this is really dumb. Like, I can't get a good spin on this. Looks roughly flat. This one would kind of go up here, so it would extend. This one would shrink, actually. And this one would shrink as well. Right. So now if I realign these, you can see it has gotten better. This vector has not changed length. However, that didn't account for the rescaling. Maybe that's just what I do. Maybe I just don't rescale it. No, because I need to know the power then. Oh, okay. Maybe what I do is I don't... Maybe I just don't rescale until the end. I observe everything's original length and look at its new length. No, because that does change the power, because these have gotten shorter. These obviously got shorter. Overall. I guess what I do is I probably look at what changed. Hey, right, drawing arrows, yeah. The rescaling should, I guess, proportionally affect things depending on how much they actually changed size. So if something got larger, then it needs to steal from something. If something got smaller, it needs to give to something. If something didn't change size, then it shouldn't change size. Do I have to do that? I could do like... I could like compute a budget after this, right? So I go through everything that changed, and I calculate the new lengths. Essentially say if something I look at that change, right? That difference. I mean, I guess maybe what I can do is I can assign each of them a difference based on what they had. So, or the largest difference. So if I see the largest difference in length is 5 centimeters, 5 centimeters becomes plus 5 centimeter becomes a positive 1. Minus 5 centimeter becomes a -1, and 0 stays at 0. So now I have a mapping where the ones that didn't change length are assigned a value of 0. The ones that increased are assigned some positive values so they can receive extra length. Or maybe it would just be the other way around. The ones that got longer need to probably be shortened, and the ones that got shorter probably need to be lengthened by some amount. Or maybe not. AES Johnny 48. I am trying to figure out some kind of balancing thing. Five stream streak, nice. And I'm just like trying to construct it visually so I can probably get an idea of what's going on. So the way that these two green arrows are the same length, right? So what this means to me is that after this like theoretical projection, the overall length now is shorter than it should be. But not by very much. It's very small. If I were to increase the length of everything, this would, whoops. This would still move over, but like, probably kind of like that. It would still be better than before. Did I just move it exactly back to where it was already sitting? I can't tell. Johnny's Silverhand. That all could have been so cool. Is this like... Why is this overlapping itself weirdly? Yeah, what is happening? Okay, strange. Dude, Cyberpunk was set up to be so good. All I can think of is those like early low quality graphic settings, Johnny Silverhand, they just look so chopped. He may never get involved with a video game ever again. I hope he doesn't. I think at this point, anyone who can afford him does not care. Anyone who can afford him is not trying to make a good game. They're trying to make money. They're trying to make money far before making even a game. But how can I rescale it such that something which didn't change size does not change size? It still doesn't change size. I'm not understanding that. Hadn't passed my greetings yet. Oh yeah, I don't know if I even said hi. Hello, R1. I just gotta think for a bit about this. Let's say I have a meter of length to give out. I'm short by a meter, I need to add a full meter back to everything. A rumored John Wick game. It's come a long way. Yeah. It's more just the... We can't keep making No Man's Sky decisions. You can't do that. I would rather a game borderline die in development hell than release and be like 10% of what it was meant to be. Because at least if it dies in development, there's always going to be someone there who is passionate enough about it and cares enough about making it good that they're going to be able to take it on for themselves and finish it. Probably with better, you know, way, way better leadership. Some people made that the norm. Some people... I still think only No Man's Sky is the game who's even been like successful. And in my mind it's because it was a studio who went from making Joe Danger, a 2D motorcycle game, to probably the most ambitious sandbox game ever devised, ever conceived. So, and they actually wanted to make it. They weren't there saying, guys, we're going to make $1 billion if we release this game. They're saying, guys, this is an awesome game and I really want to make it. And they have the right mindset, at least, where if something is bad, they're gonna fix it. Not like some games where, like, everyone is just nodding their head and saying, yeah, that's awesome, cool. They're not making devlogs of them unboxing, opening up their loot boxes, saying, yes, that's what I want, great, put that in the devlog, upload that to YouTube. When it comes to Desert, somehow turn things around in days, not weeks. I don't know what they've done, but from their trailers, it seemed like they pretty much had everything. They were like kind of done. They're definitely in the content phase. It is a lot easier to make changes in content phase. Especially if, I think what I heard was that content was the problem. The quality of content was not good. If you come out and you say, hey, we're gonna be able to like have giant space battles, and you don't have space battles as a mechanic at all yet, then that's difficult to do. So are they just uploading patches and fixes and stuff? Fix stuff that was already built? Yeah. Yeah, No Man's Sky released before they were even done with the mechanics. They're probably like 50% done with whatever mechanics they had, were like 80% done. It wasn't like patching, parameter tuning for anything with them. And they were just like lacking content straight up. They hadn't even really made it to content phase. No Man's Sky would have released a lot better if it was marketed as a demo and it wasn't hyped up so much. Cyberpunk was like they were halfway done with the mechanics and then they made all the content. Which is kind of weird. This is rolling, hopefully. I mean, the gold standard for, like, you know, modern game releases is you're doing balance changes and you're adding new content. Doing bug fixes, balancing, adding content after release. You're not working on game mechanics. There's a recent bug with Overwatch's April Fool's mode, which it seems like it was pretty much guaranteed 100% of the time. On a certain map, if you die and change hero while you're respawning, you will never respawn. You will be essentially removed from the game until it ends. You just don't respawn anymore. Your timer hits 0 and you just don't spawn. And you can only just watch the game happen. Yeah. It happened to me. And then I saw it happen to another person who was streaming it at the time. And they did the exact same thing. They died, they opened up the hero select, picked a different hero, and they didn't respawn. And it was like 2 other people on their team did the same exact thing. They were all swapping to see what would happen, and then it just broke. You got an exit game you don't want to be in. It's where I was going with that is saying that kind of bug shouldn't even make it to a release. Stuff like that shouldn't even make it. You are literally unable to play the game because of a bug. It didn't take anything weird. You didn't have to say like, oh, go to this corner, face exactly 90 degrees up, and press these keys in this order. And you have to have the timing frame perfect, and then your game is soft locked. This is like you open up the UI, you click a button, and you're forever out of the game. Like effectively, like opening the pause menu crashes the game with 100% guaranteed probability. Kind of a bug. I mean, at least they never let those bugs get through. I have not seen a game that crashes when you press pause. Guaranteed. As far as I'm aware, there were kind of things like that, not like preventing you from playing the game, but just kind of like ridiculous, obvious bugs that were not even hard to set up. They just happen in Cyberpunk. And it's like, why? Like, they're definitely... They must have seen it. I can't imagine that a playtest didn't reveal some things. And it just was like on their board of bugs to fix, and they just didn't do it. They released anyway, knowing that they were releasing horrible bugs that would undoubtedly ruin someone's experience if they happen. And it's kind of likely that it's gonna happen. Little things that slip through. I don't know how Overwatch let that one out. I mean, that's literally like, you go to the playtest, you load into the game, you pick a hero, you die, you pick a new hero. That is like, that's not even the kind of test you're thinking about. That is just like, I'm gonna go in to this new mode we've made and I'm gonna play it. And oh, wait a second, I'm not respawning. It was like kind of an in-depth one. I don't know like anything about the details for it, but it was like a certain map. Every hero is converted to Winston, and I think every hero still has like certain passives or something applying to. So you could be like a healing Winston, you could be a damage Winston, a tank Winston, and then I think every hero individually probably had something different with them. But you couldn't find out because you just couldn't change. Right. Anyway, I mean, it's just that case where it says, where they say, yeah, people are going to drop our game and never give it a chance again. But hey, they're probably gonna buy it anyway. So we're not actually losing money by releasing this in this state. Dude, the one crazy thing with I had a friend who bought a hard copy version of it. I don't know if they had fixed that one. I don't know if it was only PlayStation or like only a certain console version. But I remember with No Man's Sky, they had stickers on the boxes to say, because the box was printed with like multiplayer, and they had stickers attached to cover up the multiplayer to say single player. Or like it doesn't contain online functionality or whatever it was. Yeah. I think it really is like there's a bonus. There's just an incentive. There's a monetary incentive somewhere in leadership every time that just says, technically, we're not gonna, you know, it's not a big deal if you delay a game by a year. Probably not. If you're being financially responsible, it should never be a big deal. You have so much money already, especially for an established studio. Especially for a studio with a publisher, I think. Basically, you go in there, you say, hey, marketing, or like, before you even start marketing, you say, all right, are we like 100% sure that we're going to be printing copies of this game months before we even start marketing? Yes or no? If it's no, you don't blow all your money on marketing. You continue working on the game. It really should be like, we have a rough idea of maybe how long it's going to be. You know, maybe you can say, all right, it's probably going to be out within a year, but we don't know a date. But it's definitely like, you don't announce a release date until the game is like actually done. In-house, it's done. The only thing you have left is playtesting. Like you've made the game, you're now just playtesting it and fixing bugs. And probably doing like tuning. And yeah, where I was going with that is like, hey, if I release the game before vacation, I get a big bonus. Or like I have a bonus deadline coming up. If I release the game, I like double my income or something crazy like that. So say, yeah, whatever. Everyone's already getting paid. Who cares if everyone's already getting paid? I'm leaving this company after the game releases, so just release it now. Yeah, I mean, at this point, it's kind of like standard procedure. Release the game early. Cancel support. Fire every developer. That's the strategy. Spend probably more on marketing than you did developing the game. No demos, no alphas or betas. No public playtesting. Secure day one sales. Release it early. Fire everybody. Cancel the game. Quit. Resign. Go to another company, do the same thing. I mean, honestly, it's more just like no one ever holds them accountable. They say they leave the studio, they resign. Oh, okay, solution, problem solved. Oh, what's that? This person's been rehired at another game studio, and now they have like a higher management position than they did before. And they are literally going to do exactly the same thing, but bigger. Pre-order. Pre-order. Pre-order that game. ESEO. Hopping to other companies. Yeah. I mean, that's what like 100% of them do. Like you hear about the big ones, but like every single person You know, you hear about layoffs in the game industry, but then every single, literally 100% of those people get rehired within a few months. 100% are rehired. Some of them go to smaller studios, some of them go to bigger studios. They all get rehired. It's more the people allowing themselves to be abused, I think. People still pre-order games, which is stupid. No one specifically goes out of their way to say, I'm not going to buy this game because here's the 10 people that I work in this game who ruined these 10 games, who had these like failed releases, right? Like we need that kind of stuff. Still got this graph thing. Are you talking about what I'm doing? Or are you talking about some graph? Or is that the map editor? I haven't thought of what to do still. Maybe what I do is I do like an absolute value. So even if something gets shorter, it still maps to some positive amount of length it can gain back. I assign everything some value between 0 and 1, and then I normalize those values. So values that are close to 0 will stay near 0. Values exactly at 0 will just stay at 0 too, whether it increases or decreases. The thing you're doing. Yeah. I mean, I wasn't. I don't know, I feel like at some point I gotta stop talking about how much I hate game developers. Industry game developers. At some point I gotta stop talking about that. Maybe not. Maybe I should maybe I should make that my mission. Anytime the topic comes up, I will hate on them as much as I feel it is appropriate. It's a love-hate relationship. It's knowing that you're doing something bad, that you're participating in something bad and doing it anyway. And not even that, but also not even talking about it. Just kind of saying, yeah, that's the way it is. No, man, go complain to your managers. Tell them go to your managers, tell them to their face, you're stupid. Stop it. Well, I'll lose my job. Okay, and they're going to have a worse game for it. They're going to end up, they're going to They fire you. The game is going to get delayed because they fired you. If they don't delay it, it's going to be worse quality when they release it. The company dies faster. If they get rid of you, the company dies faster. A single employee. And don't be nice about it. Don't be nice about it. They are way less nice back to you, probably. They would fire you if it meant an extra $100 to their paycheck. They really would. But they can't do that because then they'd have to... They're also in the chain. They also get fired if the guy above them thinks they need to be fired. It's also like, you know, if half your developers show up and say, hey, we're not going to work on this game until you stop making us do this stupid thing. The company's going to be like, well... We fire everybody, and the game dies. Studio dies. On the spot. Or... we listen to them, we stop doing the stupid thing, and the game is going to come out faster. It's not going to have this stupid feature in it, or this stupid thing in it, and it'll be better quality for it. And then what's going to happen is the people who stood to make money from a good release make more money, and they realize, hey, you know what? Maybe this isn't so bad. Maybe we can do this. Maybe it's fine to listen to our developers and you know, make decisions based on their feedback. Make decisions in the direction of the feedback given. Hey, implementing loot boxes into the game mode, into our Halo 5 Warzone game mode, maybe paid loot boxes, we should not do that. We take it out. Halo 5 is literally a better game. It literally becomes a better game if Warzone wasn't like that. Maybe they fix that bug where the elites jump onto a warthog and they T-pose on the warthog turret and they're invincible. I think is what happened. Loot boxes integrated into the game mode, or elites do not T-pose and go invulnerable when they jump onto a warthog turret. Which one? I mean, that's literally straight up a case where if every developer who was told to put loot boxes into that game mode said no, it doesn't get in the it doesn't happen. And then they can spend the months developing that on something that actually is fun. And bug fixes. Alright, I think that's it. I think that's what I do. The rescale, I take an absolute value from 0 to 1, taking its absolute change as the max. So I find the maximum absolute change. And then, so if the length of everything has to increase, we overall got shorter, everything will increase proportionally to how much its length changed at all. So in this case, I think it kind of looks like most of these probably changed their length about the same amount. Just like kind of how things look. This one got a little bit longer, this one got longer by about the exact same, or shorter by about the exact same amount, and this one got probably like twice as short. So it's like 1, 1, and 2. So these would receive a quarter of the length increase, a quarter of the length increase, and then half the length increase. And this one would get 0 because this length literally didn't change at all. And even if it was a little bit different, even if it was like this, it would still probably barely change length ever. Okay. So for, well, yeah, the scale I encode as just yeah, whenever I do the shifting, I just shift it on the XZ plane, but I keep that Y coordinate in there. I project it back onto itself. At that point, its length has changed. But its direction has not changed. So do I need that third value? I mean, I guess I don't. Because then what I do is I just compare all the length changes. So if one is twice as long as it was before, then I give it twice the power. If one is slightly shorter than it was before, then I give it that fraction less power. But the iterations are still done on like a 2D plane, because I'm ignoring that Y coordinate. But I get the three-dimensional aspect of that, where the angle in 3D space still matters. Target a generate a target point, which will just be inside. And then I will shift so I still need to shift everything over. That's not right. Okay. So everything's in there, it's still 3D. And then what I'll do is I'll just say target. I can just, well, I mean, I can leave it there. There's no real reason to set that. Whenever I compute the distance, I will just be not using that value. I just won't be using the Y coordinate. Which means iterate does have to change. Midpoint. So yeah, I can get this midpoint, and then I just cut. Okay, I'm just gonna have to copy this. Because it needs to be different. I'll put it here. Have the current working result, the original value, so that I know their lengths. And I'll just be dropping multiplier, because now we're back into 2D land, which means that is the ideal thing. So yeah, I can just take sum all these up. And then at this point I can do that y coordinate, zero it out. So now we're just shifting everything horizontally and not up and down. Yeah, but then I have this rescale, which is essentially the change in length. I want it to be specifically the change in length though. Because then I need to share that among other ones based on their own change. So I guess what I can say is I can say so do deltas. And then I can say I want the old length. Let's just say deltas. Add that, and then have absolute value. Yep. And then I'm collecting the highest, the largest value of these. Oh, this should just be 0, I guess. So I've collected the max delta change. So this can be my how much I'm sharing. So everything, can I do this like in a simpler way without having to iterate it again? So it looks like I have to iterate this like 3 times. Yeah, okay. So then I need to normalize them. Actually, no, yeah, I can sum it up here. I can sum up the normalization here. Essentially whatever is the max gets normalized to 1. Zeros just stay at 0. So it'd be the value over the max. But then that's not the first thing. That's a mapping. And then I need to normalize it such that the total of all those values added together is 1. I guess what I can do is I can add up the total deltas because then that's my normalization, and I can normalize first and then map. So then I can do it with 2 loops. So now at this point, I can normalize and then map. Because now I have the total, that value over the total, would be its normalized value. And then I multiply, and then I put that over the max, which gives me the mapping. So I can do it all in one go. Normalize, map, rescale. So the first thing I do is I would put it over delta total. So this is a normalization. And then I map it by putting it over the max delta. And it looks like I can take a division out of this. If dividing is the same as multiplying by the inverse. Does that mean I could do deltas times max delta over delta total? It's like x over y over z. Hey, Raiden. What Overwatch? Big man, large guy, pal. How do I simplify this line? You see what I'm looking at? I can simplify this by using a multiplication somewhere. Is it deltas times max delta over the delta total? Delta times max over total would be the same as deltas over total over max. I think that's it. I'm on a Halo, I'm lucky now. I'm just totally blanking out on this. If I can correct this to have a multiplication instead of 2 divisions. Would it be deltas times max over total is equivalent to this? I don't think so. What are you talking about? Is this true? Oh, actually, no. That's not equivalent. Never mind. That's not what I am actually doing here. Jeez. Plug in some examples. I don't think so. This is how the real ones do math. It is x over yz. Plug it into Wolfram Alpha and tell me the solution. All right, so the delta over the total times the max, which since I'm writing it this way, now I can do a divide equals. So this gives me a value, a normalized mapped value. And now I have I still need to know if I'm adding or taking away. So I still need the rescale. So then a rescale becomes a reduction or an increase. So it should just be, I can just subtract the original length. So if rescale is larger, I need to make it smaller. Okay, so it's actually supposed to be length minus rescale. And now I do result I need to give it its proportion of this length, which is now delta. But it's different. I'm adding or subtracting a straight length to it. So it would be like, did I call it norm? I don't have a normalization function. Why am I doing an absolute value? What is this? There's a new live service game release. Wait. Okay, I get it. What you're saying. 2 days ago, Unknown and Dead on arrival, even rated for YouTubers don't know about it. Last flag. You're tracking live service games. I think you need to be planted to succeed. The great thing about software is you don't have to be very successful to be very successful. You don't even have to sell a service. You can just straight up purely scam people. You can run a business whose entire business mission is to destroy the businesses that hire you, and you will still be successful. As in, be a live support company. You practically don't even have to do any work. Okay, is all this right? Women's Meat doing amazing. Not even do something unique. I think uniqueness was lost a long time ago. You don't have to be unique anymore. You don't have to be good. If you're an indie dev, just make something good. At this point, I feel like if you just go on YouTube and you see what YouTube, Twitch, any content creator, and you see the games that they're playing, they're not unique. They're not playing unique games. They're playing the same game made by a different person. Over and over and over again, and they keep doing really well. I feel like only 5 years into the cycle are people starting to realize, hey, these are all just like slop, low poly, low texture quality horror games that just do exactly the same thing every time, made in a week, charging $10, and 100,000 people are buying it. Maybe we should stop doing that. Like, I feel like it's only now, after years of that happening, are people starting to realize that's what indie games are now. They're just the same game. People just keep making the same game. So much so that I think it's even getting to the point where people are like, normal people are recognizing the assets in the asset flips. I think there's a house model that has been used in like several horror games just straight up reused. Not even by the same developer, just totally different developers make the same game using the same assets, and they both do really well. Should sell them my house. That's the unfortunate thing. You can't sell the assets. The assets are free, or else they're not going to be in anyone's game. If you charge, they're never gonna be in someone's game. I mean, you might still make money, but definitely you're not gonna sell. The money is in, yeah. CC0, that is what you should do. Also, but probably just don't, because then you're feeding the fuel for that. You're making it easier for people to make asset flips if you provide the assets for free. Make high quality assets, because then big studios will buy them. It's I don't know if this even happens, but I'm sure it probably does, where people get job offers to do modeling because they find them on like premium model websites. So spend like a week making a really high quality chair and then sell it for $15. Some insane price. A single chair, $15. Not that good at Blender. Is this right? I mean, I think this is what the math should be, but now I kind of don't like it because I could zero a vector. I could reverse a vector. I mean, maybe the math just works out that won't happen. Oh, checks on Blender completely gone. Yeah, I know what you mean. Honestly, I don't know how, because I feel like I haven't used. Maybe it's because I spent some time using Blender a lot. But it's like I open up Blender and I'm remembering keybinds to do certain things. And I know how to navigate. The only difference is I have like a different keyboard layout now, which means that I think I still have the buttons memorized by the key name and not the key position. That's how I remember them. Which kind of sucks, because I think part of it is that the key... Actually, no, I think in Blender, because there's so many things you can do, they are organized by some sort of like naming convention. Yeah, Control Z is always Control Z is a stable. Is this right? I take the normalized vector. I guess in this case I can take original. The normalization of the original one multiplied by, so it's just a length vector. It's just a unit vector. And then I scale it to be the length of this result plus the rescale times however much of the rescale it gets. But what I was thinking of here was, do I need the normalization? Do I have to normalize? Oh, and then I don't have to do return there at all because I write it directly. All right. So the points. Now I need a result. And I think what I'll do is if things are passed by reference with these arrays, at least in this version, which is what I'll be using. So I can pass, I can have like a results. Yeah. And then I would flip these around every time. So what do I need to say? I need to know the last error that I had. I just write -1 instead of 1.0. And then I can have last results is it points.copy? Yeah. And this I just is null like that? What is it? None. It's none. Okay. Jeez. None. Okay. So yeah, just take the sum, I cut that, and then I shift by that, and then I do the projection. And then I rescale. And this took a little bit extra stuff now to get that rescaling to work. Okay, so I just say iterate gravity using well, essentially I'm swapping these two out. These are both arrays. Yeah, what am I doing? I have two versions of this. I can't really swap these out like that. Never mind. Also, I even found that this copy is just so small that it didn't even, apparently it doesn't even matter. The real speed killer was just actually doing this part, the iteration itself. Whatever, can I not? No, because if I do, then I would have to swap it out. I still have to copy the values over, so I may as well just copy it every time. Okay. Now, I don't know if stuff is forward declared. Oh, it is as long as I run it down here. Because it will have run over that definition and defined it, and then by the time it's actually called, it's already been defined. Okay. Iterate gravity, results, points, and then I have to calculate the length of these points. Yeah. And I can add them up at the same time too. So I iterate gravity. And I compute the error, which is going to be looking at the result of adding all these up, cutting out, and then comparing. Yeah. The target. Okay, so if I'm gonna compare the target, then I may as well. Yeah, because the midpoint, I trim that out and I slide them over. Right, okay, okay. So I cut target out there. And then error is... I guess I can just start with results. I think that's it. Let's retire early. See you guys later. See you, everyone. Thanks for hanging out. Error is this. Yeah, just the length of adding them all up. Not quite. So I add these all up, and then I get rid of the y coordinate. And then I just pass it in like that. Thank you for streaming. Yeah. I really hope once I get through all this, I regain a lot of motivation to work on this. Because recently it does feel more like, I have to make myself work on this. Which I'm sure I can only handle that for so long. Okay, so I've computed the error. And then I compare the errors. So if the error gets worse, then I stop early. I save the number of iterations that I made. Just like +1, I guess. And I guess here I can actually just subtract one before I do that, so the iteration stays. Or maybe I just... this. There we go. Otherwise, if it fails, then I say results equals last results and break. Is that right? That is what I should do. I guess I forgot to do that. Well, I didn't do that up there. So I can do a print. I can say, is it on Overwatch yet? Probably no Overwatch today. Probably. Though I am past, or I should have taken a break. Yeah. Alright, I'm just gonna take a short break. I'll be back. I gotta set timers for that. Yeah. I'll be back. I'm back. I forgot I was gonna come back to Doom music. All right. Okay. Ready to go. So I have the results, I have the error, or I guess the last error. Right. B? Not. What? They all say converged? That's weird. I guess I should be sure that the length correction is working. What the? What? It's actually so wrong. It's actually so wrong. Did I see what the iteration says? 1, 1. Why are they printing with this stupid plus minus thing? It's really silly. Uh. Okay, so I'm just completely wrong. The rescale is just not correct at all. So I get the rescale. This is how much I want to add. I mean, I guess I can print out the deltas. Because delta should be sum up to 1. I'm hitting GM tonight. Okay, good luck. Those look like good. Like good? Oh, wait. There we go. What do you mean good luck? That's just a lot to do? Okay, yeah, so this one's like 0.3 and then this one's 1.5, so that's definitely not correct. What did I do wrong? I mean, I guess just my entire approach was wrong. Deltas is the change in length. The absolute change in length. Let me just do like one set. Let's make it easy. I don't understand how that's like that. What do you mean? What else am I printing? No, how does it make any sense? How does this one grow by a meter? How does 0.2 grow? Oh. No, I see it. Am I midpoint multiplied by 2 over count? How is it changing that much? Okay, let's just do one iteration. The y coordinates are just kind of changing like crazy. Okay. Okay. So what I do is I say that I have this much to apply back. I have the max, and I have the total. I can normalize with a total. And I can map it with the max. Yeah, I mean, that's already, like, obviously immediately wrong. Okay. Okay, so I'm just divided by the max delta. This does a mapping from 0 to 1. Yep, so the max becomes 1, and then everything else essentially... Well, everything else actually increased, right? Okay. And then I would normalize this value such that it's the sum of all these. I sum all these together. It's like I know them at the same time though, which is weird. Hey Demon, what is all this? Ah. Why did I think this would work? Oh wait, am I multiplying these together? If you don't know what you were doing. I do. I think I can just do this all in one shot at the same time though. Delta over the total is the normalization. This is the mapping. So what if I multiply this by... No, that doesn't make any sense, because now what I'm doing is I'm just deleting that part, essentially. Okay. I feed this to here, so I don't have to do it myself. Does it know what I'm asking? No. It does not know what I asked. Whatever. Just wants to do math, doesn't want to make a game. Yeah. You got me. Yeah, do you like that? Snumpy raycast. Why is this not this? It's dividing by the sum. I don't know what he could have been barking at. I see nothing. It is empty. So I print the deltas. I print the rescale. What's the delta total? Okay. I'm back. I now see what he's barking at. Alright, so... this is the original delta list. Okay, so I have that total. There's a total and there's the max. So the first thing I do is I take it by the max. So I divide it by the largest value. Okay. So it's now been mapped. And then is normalize even the right word for what I'm trying to do? It's more like, I don't know. Normalize in some sense. Oh no, it is normalizing, because I said, yeah, I mean, it is just like normalizing a vector. So what is this sum? Okay, so there's the sum there. Can I construct this from either of those two numbers originally? Here's my thought, is maybe I can do... do these two numbers actually map out like that? To exactly the same value? Oh. And then I'll just divide it by that. So the operation would be L multiplied by because what I did first was I took it, I divided it L divided by um, this is the max. Just middle click. Game 1 Winton win. Cool. And then total was this value. So the sum of the normalized is the exact same as doing the total over the max. So L would be equal to L divided by... yeah, the first thing I do is divide it by the max. And then I take that and divide it by total over the max. Oh. Which would be the same thing as multiplying by the inverse, which is the same thing as doing L divided by the total. So what I do is I just take my input array and divide it by the total. So I'm stupid. Why did I not think I could do that? I mean, I guess I just am. So I just take the deltas, divide it by the total delta. Okay, and then nothing happened. So. Oh, because I... Right. I should just do that so I can actually see it. Okay. Let me print the initial error. Jeez. All right. Um, then the results that I actually want is going to be an array of factors. If I do... Alright, cool. That's what I want to see. No, that's not what I want to see. I want to get the lengths of each of these. And then sum that. Whatever, I'll just write it out. Objective type int has, am I? Yes. Why are they numpy floats? Whatever. Okay. And then I will go ahead and drop these prints. And then I can visualize this. I can see what I got. And in fact, I'll let it do way more than that. I'll run that again, because this one just kind of seems like it really sucks. Alright, this is a really good value. Because this is worse than after 3 iterations, it got to 7 centimeters, and this was 50, and it got to 48 centimeters. That's just... I'm gonna assume that one just really sucked, whatever it was. I mean, it looks like it had... Okay, it was missing a degree of freedom. Sort of. I don't know. Initial error 2, final error after 50, pretty much on the dot. So yeah, I'll go put all these into this 3D. Quickly fix it. Oh, I have one that's like... I'm surprised the other one didn't converge. Because it is running in 2 dimensions. Which I mean, I'm assuming that one just sucked. Like, that was just... It had some kind of crazy setup that just made it nearly impossible to function. Gang 2. That doesn't look like a result of the game. Oh. Can I say Y down? Yep. Well, I guess I just gotta fix... Alright, here's what I'll do. I'll just run this again, and because I don't want to recopy and fix that every time. So I'm just gonna make it work with Z up. I'm just gonna make it work with Z up. I just hit U, which means I undid something. Okay. Z up. Okay, that should just be the same. Alright, I gotta go. Oh, there is a multiplier that's like 2.5, which is fine. I mean, these are like crazy examples. Okay. And then these were the results. What I want to do is, I guess, say like, um, I'll do this, I guess. What? Okay. Oh, that's just point down. Okay, good. Now I'm worried about something. I'm looking for one that has a certain layout for the X and Z coordinates. Oh, perfect. There it is. Oh, wait, and this one converged. Okay. What I was looking for is for every point to be in a different quadrant of the plot. Because I was kind of... I mean, I guess I shouldn't have been, because when I was testing this on 2 dimensions, I actually made exactly this layout and it worked that way. So you see I have a point in every quadrant. I mean, roughly every quadrant. This one's barely in the top right. But this one actually, like, hit a convergence. Which is the first time I've actually seen that. And it's probably also the first time I've seen one where there's a coordinate in every place. And they're also all negative on the z-axis as well, which is a common occurrence. So I don't know what the chances of me getting this were, just randomly, but it happened pretty quickly. So what this is saying is the 2 back legs should, this back leg should reduce a lot. This front leg should increase a lot. This right leg should reduce a little bit, and this one should increase a little bit. And it converged in 45 iterations to literally floating point 64-bit, in fact, floating point precision. So I guess I'm curious about what happens when it reaches so I'm looking for it again where it gets a specific layout of the legs, and that's it. It was within a centimeter after 8 iterations. It did not converge, but this is basically, it pretty much was on the dot of converging. Multipliers. This one's kind of crazy. But most of these are, I mean, this is probably just a really kind of a wild one, isn't it? These two numbers are almost the same. Okay. Let me look at this one. So this one was just about to converge, but it was within a centimeter of accuracy after 8 runs. Which is really good. Which means I could probably just do like 10 runs and usually guarantee a very precise result. And they were all negative again too. I mean, the y coordinate is actually just doesn't really even matter. The y coordinate being a small value just means that, or more or less the y-coordinates all being roughly the same is beneficial. When they're dramatically different, then it has... I don't know why it's spinning. I don't know why it spins when I do that. Hopefully just by the end of this, it's it actually does work. That the theory behind this is actually good. Get a lot more, this one got a lot less. This one got less, this one got less. Yeah. Though I haven't gotten to test a vector that exists pointing directly, pointing straight down. But my hope is that because I grow the length prior to projection, then reproject it, vectors that are pointing nearly straight down should basically never get moved, ever. They basically just shouldn't get moved. I can look for a case where a vector is nearly straight down. Just the first two coordinates need to be almost 0. Initially, almost 0. It's probably really not likely to get that to happen. I have a very small vector. And this one has a crazy result too. This one is like grown by 7. The first vector grew by 7. I feel like I'm sitting at a slot machine. Waiting to hit zeros. I should probably just force it to happen. Okay, I'll just make it so that one of these vectors is going to be 0. But it will have a length down. Oh, that's up. This should be down. Okay, do a run. Why are you pretending like... What? Huh? Oh, because I move it. Okay, so I think... Like, yeah, I just do this. Target... well, I actually could just map it afterwards. No, because then the length is there. Okay, so just... Yeah, just do that. Okay, now I have a vector perfectly at 0. And it didn't move. It didn't move. Great. It was small in 6 runs. It converged in 38. So on top of that was also just kind of good. Kind of a good setup. Or a roughly triangular setup is what I'm going to guess. They were all about as perpendicular to each other as they could be. Yeah, I mean, it looks like actually a perfect triangle. Well, I mean... No, yeah, it's a really good triangle. I was going to say, I guess in this case it would be impossible if you just remove any 3 points roughly forms a triangle. Or any 3 points does form a triangle, it's just that sometimes those triangles look really bad. Yeah, this was actually a good large triangle without any, like, it wasn't a super thin triangle. So this like got a lot more force to it. This one got a lot less, this one got a little bit less. And those roughly centered up. Okay. And this was small in 6. And I can pretty much guarantee that usually they're going to be in a pretty good looking shape. Now I will test from 2 to 8. 50 iterations each. See what happens. Oh, whoops. I don't want to do this anymore. I tested it. It works. Well, one of these, those look really weird. Testing 2 legs. This one basically can't ever correct. And I can't click and drag. This one also basically cannot correct. It can correct a little bit, but not really. This one technically convert. I mean, yeah, these just are bad. Oh wait, they just kind of suck the whole time. And then 6 legs was actually the first point at which it was kind of okay. This one had literally no negative motion. Someone was cooked from the start. This one had no negative X motion. Someone was busted. This one had no positive motion, so it's busted. Okay, so I just got like 3 totally chopped ones in a row. And this was the first one that actually had any possible degrees of freedom to do anything, and it did get small in 9. This one has it doesn't really have just like a negative X value, but it did get small. Okay. This one's got one of everything at least, and it got small in 15. Okay. Yeah, let me fix this one. Delete that. Alright, run it again. Real test. 2 legs. This was actually an ideal setup. They're kind of opposing each other a little bit. But these coordinates are really small. And it did get small in 17. This one's probably possible. It didn't do well. These aren't even good like leg layouts. It does seem like when they are good, they have most. This one doesn't really have much freedom, but it did do well. This one also doesn't have much freedom, but it did really well. I guess I should look at the multipliers and make sure I'm not seeing any explosive multipliers. This one has a 3, which is kind of insane. But this was just a busted layout too. It didn't really have a way to do a negative Z anywhere on the other ones. Ideally, one of these two would have had a negative on the Z as well. This one did really well. It even converged. 6 legs. It has every axis of freedom. Any insane multipliers? There's a 2 point... That one's kind of crazy. That one's pretty good. A 7. This one has a 7. Yeah, that one's just not happening. That's insane. I guess ones that are really close to the center already kind of get blown up because it's trying to use that one. And since it doesn't account for the Y. Yeah. I mean, but that's probably fine though. It's probably fine. Because this one was roughly underneath it. Let me see what the leg layout is of this one. Basically, I'm just hoping to see that this has like something really insane about it. Like it's like a leg layout that's probably just never going to be seen. I'm seeing a lot of 2s. Yeah, there are 3 2s in the x-axis. So it is kind of a crazy layout. And if this was like the only... Okay, yeah, this is just an insane leg layout. This was the only... Yeah, there's only a single way it could go left, and it could barely do that. And it had 3 legs at 2 meters to the right. So that one totally makes sense that this one had, like, exploded. And left the only one that could go left with a 7 times multiplier. So that makes sense. Generally good layouts when if they converge. This one was pretty much there in 5. This one converged and was there in 7. Yeah, okay, cool. Oh, wait a second. This one's actually really cool to look at. Hang on. it took in these vectors. Oh, it took in these two, which one's positive x, negative x, positive z, and it came out with essentially the mirror opposite vectors. Positive 044225, positive 044222, negative 5614, positive 5614. So that's exactly what I would have wanted to see. Though it does mean that, at least in this case, one of the legs was doing double. Okay, well, if my initial assumption, which was that doing this process could produce multipliers in this sense, was correct, then this seems like it's working. Seems like it's it will work. I have written it up. It could work. If it could work, then it will work. That's what I'll say. Okay. So calculate leg gravity power. Just gonna run through the code. I don't know why I had body mass up here and then I didn't even use it. Whatever. Okay. So I have a target point. I have 3D points. Okay, so I guess the first thing I have to do is I have to get leg positions as a vector 3 array. And the target, yeah, can just be a vector 2. Because I'm excluding one of the axes. So then I have to have so I have the leg polygon in order to find the mass center. But then I would just be using the original leg positions. Or the spring midpoints is what I'm using. Which I was caching it to avoid like an array copy here, but I kind of have to give it an array copy. Does the packed vector 3 arrays have like a filter? I can do filter. I mean, it's technically in the leg update data, so I could just use that. It's from the leg polygon. So, I mean, I can just assume that I'm getting these things in that way. But no, I don't really want to do that. I want to make it a better function. So I need to, yeah, I have to collect the midpoints. Whoa. I think something was flying in my face there. So apply ground forces should be the same as... This gives me the grounded leg count. So I can resize it to grounded leg count. And then I would just grab the spring midpoint. Like update data. Oh. Okay, I just have to make it up here at the top. Which is actually just super annoying. Just have to copy the... Alright, I'll just do this. I'll build them. I'll build it all from here. For my games, still not over. I mean, you should be. You should be. Second step, obtain leg positions as do I obtain it as the spring point? I mean, the leg polygon should be made from the spring points. Because that's where I apply the force, which affects if that's where I'm applying the force. I mean, I guess I could physically apply it to the leg position. But no, I can't do that because then I have to apply an impulse twice. Applying 2 impulses. I mean, it doesn't update the it uses its current rotation, which is what I'm doing down here. If I do a rotation, then I have to tell it to update for the inertia stuff. But this doesn't change the rotation of it either. So I can do the force vector and then get a gravity and apply those impulses separately. The force vector at the spring midpoint, and then the gravity at the leg position. I mean, I guess the problem with doing that one is that it does mean I start with a higher error and it takes longer to collapse. It takes longer to get to a good value. If I start with a low value already, like the spring midpoints, then I'm better. But that means the leg polygon has to be changed to be the spring midpoints. I mean, hang on, let me think about this. I could compute the forces for... I mean, ultimately what it really means is going down from a very dynamic position to a fixed position on the body. By using the spring midpoint, it's like a halfway between those two. I'm using the dynamic position, half of that, and I'm using half of the fixed position of the body, which means if I can compute using leg positions, but then apply at the spring midpoint. Which means whatever I computed will be a little bit better. If I do it. It's probably, it probably is good to do it that way. It probably is just fine to leave it like that. Okay. The target gravity point that lies within the leg polygon. Done that. Obtain the leg positions. And then I can actually just use the polygon in this case. So, in fact, I'll just take in the polygon. Oh, no. Because I need that third dimension to know the true amount of force that I've done. Right. Okay. I mean, I could go through the polygon and just save the y coordinates. I could also create... Oh my gosh. Okay. I gotta stop talking. I'm driving myself in a bad way right there. I'm using the 2D polygon to get the center. But I need that third, I need that y coordinate. Which is the like ground point. The polygon needs to be ordered so that I can properly step through the segments. So I know where the segments are. But the actual leg positions don't have to be ordered at all. It literally doesn't matter. They can be in any order. So what I can do is I can just run through the legs. I can just save their positions. Their grounded leg positions. What's that going through? Jeez. They're making stupid sounds. It is a little bit annoying how many... I mean, I have to have at least 3 because I have to do this pre-update. I have to do that for all of them. And then I have to do the checklist step for all of them. And then I can do the update for all of them. These are very necessary in their layout. But then I'm doing this. And this is just really collecting data. I mean, I guess that's not already known, because this origin point is moving every time. Okay, I need to start. There's a lot of cleanup that can be done with this to improve it, but I don't need to worry about it. I'm talking myself crazy, I think. When you're putting a grapple hook in, not gonna have that. What are you doing? Does a crawler work? I'm making it not do crazy spinning when it's like sideways, walking up a wall. Because what happens is it lifts 3 legs, and so its other 3 legs make a triangle. And these 2 legs are pushing up, and this leg is pushing up with like a third, and these 2 have like 2/3 of the force, so it like spins really bad, really, really quickly when it starts walking up the wall. Yeah. So I'm tackling a generic solution to gravity, which also means I get this. Each leg will apply a varying amount of gravity negation force, which also means that when it's walking on something that can move, that thing actually receives the right amount of force as well. Because the alternative to that is just making it so the 3 remaining legs just split the force center of mass. But then if the objects that each one of those grounds are touching are different, they'll experience force in very... If it was one object, it would probably be fine to just do the same thing, apply that same force at the center of their leg positions or just at the center of the body. But if it's like 3 different objects, every single one of those objects is going to like rotate in really hard. They're just going to like spin for some reason, which will just look weird. They would all instead just go straight down because they're being applied at that point some gravity force. Otherwise it'd be like the force is applying to some point outside of it. And now lost what I was doing. Okay, that's right. When I apply it to the ground, I probably should apply it directly to the contact point, right? I mean, I guess if I think of the force on the crawler, it's fine to leave that force positioned like outside of the body, pointing whichever way it's going. But then I take the opposite of that, and I probably need to slide that down to the contact point, and that is how I apply the force to the ground. Oh, well, it actually just means I literally apply it to the leg ground point. Right, is that spring midpoint is relative to the trend to this. Yeah, okay, so I actually slide it. It's already the same vector. I just make it. That's actually correct. Because that is the real point of contact. Okay. Okay. Alright, calculate like gravity power. I am starting I need this length value. So I have to get the length. I have to reproject all the points. And then I collect the length in one shot. Okay. And then I create it and then pass it, and then I don't reuse it. So I'll just mark that okay. These are not a reference, so paste this whole script into Claude and tell it to finish up. I mean, I'm just transferring the code at this point. Okay. And then I'll do this, I guess. Last error is going to be why do they just miss a lot of like very obvious? Yeah. They say as a downside are less flexible. There's no reason for them to be less flexible. There's literally not a reason. You can still have all these templated functions in there and it does not make it consume more memory or run slower by having a function available to you. Everything should be packed. Arrays should just be like a typeless array. And whenever you do a typed array, it's a packed array. Very silly. So yeah, I have to compute the error of this set, which means adding up everything, zeroing that, and then getting the length of it. Good. I just call this points. Also, since I'm not really recording this, I can just do length squared. It doesn't matter that it's not the correct length. This one matters, but this one doesn't matter. So I need a results array to modify. And then I also need to track a prior result. Which I'll actually just leave typeless instead. No. I don't know if that makes it slower or not. It probably would. I don't need to track iterations or converged or small. I can just have my max iterations value. Most of this at the top. I'll say 10. Okay. So then I copy over last results. Is there like a way to really... No, okay. I might even run into problems because I think duplicate, because of how they do this, and this is really dumb way that they do it, it's a copy on write, which means even though I say duplicate, it actually starts with a reference. And only when I modify this does it then create the copy. Which means if I assign it, if I duplicate into it and then I modify the other thing, it might... Does it know? Does that one then know, oh, someone has taken a reference to me, I need to make a copy now? But then when that one changes, then it's going to make a copy anyway. I'll find out. It might just be totally, like, annoying. Yeah, you know what? I actually just hate that so much. Fact vector 3 array of results. Like, I'm forcing it to do this because I want to keep a copy of this and then modify results, which I just have a crazy suspicion that doing that is going to be weird. This one's going to be still pointing at the modified version of this as I modify it. And then I'm like, oh, I'm pretty sure it's modifying. And then I call print on it, and then it fixes itself and starts displaying a different value. But I'm like, okay, but no, when I actually read it through code, it's giving me this result, and when I print it, it's giving me a different result. That's literally happened. I've literally seen it printing, and like the print fixes the error. And then I get rid of the print, and then it's broken again. Stupid design. Just stupid design. I don't even want to test it. I don't want to find out. So I do the copy, and then I call iterate, and iterate does this, which I can just basically copy it in there myself. I don't need to run length like that, but I do need like everything else. I may as well put it in its own function because it doesn't... I mean, it doesn't actually return early. And I'm not really saving an indentation by doing it, so not really. I am saving one by doing it, but I won't. So do I need absolutely everything here? I probably do. Fortunately, I already have point count, so I have to take a count again. I can even pre-compute this constant, because I know I'm going to be multiplying by the same thing every time. Okay, so to start with this. Oh, actually, I guess what I say is if I have, yeah, if the point count is 1, I'm just returning 1. Maximum force that I can apply. You are hogging out, awesome. That's great. Honestly, I want to see Overwatch be the first game ever to break the stigma of not removing characters from your live service game. There's a couple characters they should probably just remove. I would be okay with Hog being removed. Or like a permanent competitive ban. Like this character is no longer available in comp. You cannot play it. Yeah, there's one, there's literally nothing to do. So just skip. Otherwise, 2 or more, we're good. The reason I noticed that was because of this value. If I do 2/1, then I'm amplifying it. So just nothing would happen. It would do its translation, and then multiply it by 2, change it, and then say, well, that didn't do anything. We just made it worse. And then it would return. Okay, so midpoint, I need to add up those so I can do some. Yes, doing results. I mean, technically, this one does only have to be a vector 2. That probably saves some time by doing that specifically. So I'll just do that. Right, and then I multiply it by that. Well, I mean, I actually do. Eh. Times the multiplier. And then I do actually need it as a vector 3. So. Okay. Got midpoint. And then I also have deltas, which I need the delta and the delta total. And I guess I can just do this up here, actually. And I kind of want to do this always. The initial value of a vector 3 is always 0. Yep. So I can just collect that. And I need delta total. Delta starts as the current length. And then I do the shift. So the result, I minus the midpoint project onto origin. This vector onto the given vector. The resulting new vector is parallel to B. Okay. They say parallel. That only really works in 2 dimensions. Since there's 3 dimensions, I would want them to say, because there are an infinite version of parallels. Just a vector here and any vector above it, but at this rotation is technically parallel to it. Specifically means it shares the same direction. Is probably what they should say. The resulting new vector will be man. Okay. So what I would probably prefer is that it just becomes 0. is a finite value, not nan. Yeah, okay. So if we're not finite, I just want 0. Or actually, maybe just stay the same. Actually, yeah, I want you to stay the same. If the new vector is finite. Yeah, then otherwise I'm just, yeah, basically just stays the same. So new length is the length of the current stored result. Which technically I can kind of drop this. Otherwise it's just gonna be this old length. Rescale and adding the length. Yeah, old length minus new length. I mean, it's kind of the case where if it's not true, then it's just going to be 0, and rescale is going to get because delta total doesn't change. Oh, I got rid of too many lines. You're balling out now? There's that part, and then I do rescale as length. That. Let's rescale. Delta's I divided by the delta total. And the result is going to be that line. Oh, what? Ooh, yeah, that's bad. There's not a single eye anywhere in here. There are eyes in here. Would it highlight it if it was like that? Okay, it does. Take the original, normalize it, and then multiply it by this change length. I could, because this is kind of expensive in the iteration, I could pre-compute this, because I do already get the length every time. So I could get, right, just do that, right. If it's approximately 0, then ditch it. Because when I resize this, it should just fill with zeros. Also, a feeling there's actually just something weird happening with how this works, which means I still have to assign them in order. I'm just actually sure I have to do that anyway. Because I think technically it reserves it, but it actually won't write any data. But it also doesn't update its like high index. So if you were to resize it to 5 and then access index 1, it's going to say out of bounds exception. But if you access 0, then it's going to say that's fine. And after you access 0, then 1 becomes fine to access. Like that. I think it's actually... Dude, Godot's packed thing is so chopped and so terrible. I'm pretty sure that's exactly how it would work. How it would work. I just got such a good feeling about that. So for point directions times this. Why not happy about that? Haulable? Oh. Duh. Okay. End of iteration code. So now I compute the error. This one doesn't matter, I can just do for that. Okay. I'm gonna say if the I don't even have last error. If error is less than last error. Because I always started as just being length squared. And then I would be increasing that, and that's just doing checks. Okay, so I don't care about that. Then otherwise, I say results as last results, and I break. Okay. And then I compute the multipliers. I don't need that much accuracy, I think. But I do need this, actually. Length of the current result over the length of the original point. So what I can do is I can do that. It's just a way to get length without recomputing it from the normalized vector using a dot product, which is just multiplications. Okay, now I have multipliers, and that's supposed to be it. So now I see what happens. Okay, so it's immediately unhappy about this. Whatever has happened, I don't know what's happened. Well, what is leg positions? No, it's size 3. How? Wait, what? Update legs. Free update. If leg apply ground forces, grounded leg count +1. Grounded leg count should be 3. So apparently I'm looking at a leg that is applying ground force, but also shouldn't be. Huh? What's my leg polygon? I saw this error before. I was like, oh, that doesn't make any sense, but then I just fixed it without really thinking about it. And now there's definitely just something wrong. Okay, so there's already 4 legs. Somehow. Leg apply ground forces is directly equivalent to grounded leg count. How is that possible? Does it? It starts to become stepping. And then it says it's not anymore. Or it wasn't stepping and now it says, or it was stepping and now it says it, which is what happened here. This happened when a leg landed, I think. One of these legs is landing. I guess probably the back one looks really close. So before the update it said we're grounded, and then after the update it said we're not grounded. So I think this just means I probably check it here is where I run this. I actually run it down here. Which means the check early step and the update cannot be reading from ground normal. So I guess let me check that. Grounded leg count and ground normal. It's not doing that. Is it reading the body ground normal? Okay. Yeah, that was the mistake. Apply ground forces. Where was this? Where was that other spot that I noticed it happened at? And I said, oh, well, just whatever, forget it. It was this one, I think. I do still see it bobbing. It looks like it's bobbing pretty hard still. It's maybe a little bit better. I don't know. Oh, I don't know why I did that. Wow, he's really rolling out. Okay. All right. Okay. So that was a test, I guess. So now I want to test doing not that. So I guess what I'll do is I'll do like if through. This is the alternative. So test with the alternative. What are you doing? That was weird. Why'd you do that? It like lurched in a weird way that I've never seen it do before. Why did you do that? This is just the same as it was before, right? It was total gravity times leg mass. Because this is the spot that I actually do any change. Total gravity times leg mass. Yeah. I do have a change there. Yeah, this is the only logical change that's happening. Yeah, I don't have any line changes. None of the additions are making a multiplication. I did change that. I did change shared mass, which was actually a fix. That was actually a fix. Because I set it, I believe. Okay, so this is 0.5. What I think I want this to be is like, yeah, I changed it to 0.4, which is how many legs are necessary to lift the body, which means it can lift. It can have half its legs and lift perfectly well, or it can have 2 legs and lift still very well. Better than it would be if it was 0.5. Okay, so I just want to make that change. It's updated there. Okay, but this should be nothing. That was just a crazy lurch. I've never seen it do that. I should probably turn off some of the yeah, I'm gonna turn off the debug stuff. That's just way too noisy. It's hard to even like pay attention to what it's really doing. So turn that off. Why is that on by default though? Why is that on by default? I need to open the scene because that was the wrong default. Okay, now that's fixed. Close that, and then I turn off. Then I go to crawler leg, and I turn these off. These need to be turned off. Yeah, I'll just turn these off. Okay. So this is unchanged. Unchanged results. pretty wobbly, right? It's wobbling. And then I'm going to tell it to just go up. It does that weird thing. It's not really spinning out though. I want to make it go sideways a little bit to see if it can do the spinning that I saw was happening. Uh-oh. What are your legs doing? Its legs are broken. It's walking with one leg right now, which is crazy. Whoa, dog! Oh my goodness. Hi. You scratched me. Dude. Alright. Dog's gotta go. He's doing me harm. Okay, this one, I don't... I'll be back. It broke its legs. I don't know. I'm back. Okay. I don't know why its legs broke. I think I'm still testing it not on right where you... Yeah, I was trying to get it to do anything, because the weird thing is, I swear, it was spinning out. It was kind of spinning out really hard. There's something that happened just then. I mean, I think it is probably only when it's sideways. Alright, you know what, let me do this. Let me make just a big sideways wall up here. I can't tell. Is this being... I can make it be cut. Okay, no, I definitely don't think I need to do that. So now I get a big flat wall back there that I can make it crawl around on. Go. It's like dropping kind of hard. Can you just rotate? Rotate. Perfect. Go there. Alright, so that's good to see. It pretty much struggles walking sideways. It really can't do that. It's like dropping. Yeah, it basically just fell off. Okay. So there's something to look for. But is that necessarily caused by this? Maybe. Maybe not. Definitely the big difference between this is that it is shared mass now. Which means 2 legs can account. In fact, you know what? Let me even go back. Let me send this back to false and see what happens on shared mass. Because that's what I really should be looking at. Go. I think I did this and it was spinning out really, really hard. Even like going in a straight line. It would start like flipping back and forth. Okay, so it didn't really do anything there. And now it can go in a pretty straight line to the side. I immediately notice that change, right? Okay. So that's an immediate change notice I'm seeing. it does well at going laterally across the wall now. Though it does seem to break its legs sometimes. Yeah. So before it was like it was dropping really hard when it was going left and right on this wall. But is it like if it goes up and down? Is it kind of rotating out pretty hard? It does really want to be sideways. Yeah, okay. So it basically could not. It pretty much immediately gave up doing that. I need to make it do better with rotation. Because it like gives up for some reason. I don't exactly know why it gives up rotating. Alright, just go all the way across in a straight line. And it's crabbing. Yeah, okay. Alright. I mean, that's not like a big deal, but that does suck. Alright, so now I use this version. My fix version. And see how it does this. Okay. It's not a good sign. That's twice now I've seen it spin out. Doing kind of nothing, but sitting there. It's crabbing. Which means it's not able to, and it flipped over. So it seems like this has just done nothing but make it worse. I think part of it is that this technically does overcorrect for gravity. That is it's allowed to overcorrect for gravity. Because one leg can suddenly apply a great deal of force. But I do have this like weird 2 limit thing. I mean, I could do this. I could do another... I could use it as a force limit instead. Where... this is allowed to go up to max force instead. It's different because I actually need to include the fact that gravity exists here. Alright, you know what if I just don't limit it? And, if leg gravity factors, leg grav index is, greater than 2. I'll say 1.5. I want to put a breakpoint. I want to see what this looks like. Because it seems like it's worse than not doing it at all. Okay, so I instantly got one that wants to be... Huh? How am I really meant to limit this? I mean, maybe what I can do is I can limit the overall length of this. Or the mo... Alright, well, I wish I was kind of looking at it, so I'll just run it again and look at it. Because it basically happened right away. Okay, so 3 legs are off the ground. I would say this is just straight up 3 legs. How do I have 4 legs reading right now? There's definitely not 4 legs on the ground. Oh, maybe there. Maybe this one is landed. So I guess I can look at leg positions. Besides that, so I can really look at this. Okay. And I've gotten these factors. So that is leg, this leg. At relative to the body, so it's positive, negative z, so it's this leg. It is this leg. Saying to apply a very high force on this leg. That was a loud sound. That was a dog or something outside. Yeah. The X and the Z. So it's in polygon order. Wait, what? What is this? Negative 1.7. What are like positions? The ground point relative to this. Okay, so I'm talking about X, it's this. It's in this direction. Z is this way. Negative 1.7, negative 0.8, and then way down here to Z left to right. I have a single negative Z leg. What? I mean, visually, no. Because, like, what leg, which... I mean, this is the one negative Z leg, which means... This is the leg that's just been grounded? This leg? It looked like this leg was grounded first. Okay. Alright, let me do this. Let me go back to the clamp. And what I'm going to do is I'm going to debug this. I'm going to turn all this on. So I'm going to draw it. Wait. I should be applying at the leg contact point, shouldn't I? Not the leg. Hmm. Where? Where? I haven't minimized it. At the so this is a global coordinate, and I take a global coordinate and I subtract the origin point. Okay. Okay. Yeah, okay. Okay. And then I want to draw vector from each leg point. How do I make this vector? I mean, I guess I just add them all up, right? Because it's... I give it the coordinates and then the vector. So when I draw it at here, and then I want to draw it in the direction of oh, right. I have to add it up over time. Okay. I'm adding um um this. Oh man, I think I. What? Now I'm trying to debug it. I don't even know how to display this. So effectively, it is a vector at this point, pointing in. Why is it wrong? I literally don't know how to display this. It is. How do I combine these? How do I display this? I mean, it's essentially this times this, right? Like that is what I'm doing. It is this times this. Total gravity vector, add that vector this length. Because it is a point, and then it has the length of that amount. Yeah. Is debug? Yeah, okay. the hell is happening to this vector? This vector's so screwed up. Oh, he even slept, but it's pretty late there. What? I have no idea what time it is for you. It could literally be morning. I wouldn't know. Ugh. If you haven't gone to sleep yet, you should go to sleep. Why is the vector displaying crazy like that? Is this the position? No, give it the center of mass. Shocked anyone would focus with Doom music playing. It's just not putting me to sleep. I was slowly falling asleep with the other music. Oh, I guess I should be doing that, shouldn't I? But then it's like rotating. Why is it rotating? Do I just not even have to rotate this? I guess I literally don't have to rotate that. It's already correct. Alright. That is kind of what I expected to see. A very large vector. Okay. It's probably just too much. So I will add the substep at each. Yeah, I was totally in the middle of trying to type body offset to execute it as a function in the middle of all that. Can that vectors with use? Okay. Thing is, it's not showing me rotations. Okay, hang on, now I'm seeing something happen. Yes, that's wrong. It should still be pointing straight up. That's just wrong. And why is the vector getting shorter? It can fully lift itself with those. Alright, times shared mass. Okay. Yeah, what was that? For a second there, it just got really bad. Okay, let me print the error. Um, like that is so small though. That's whoa, 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 what? 19? What? What do I see at 3? What is happening? Can I like what? 117. Okay. So those are really bad errors. Three. This one is 3. Alright, let me do this. If we're greater than that, that's a problem. I want to be able to stop right in here and see what the points were. And see if... See what it would be if it was if it did more iterations, or like what the legs are at, or like what's going on with that. Because I've got an error before it's like done anything. It's done really nothing. Last error 0.216. How is there like a -3 on one of these? I mean, I guess it's possible. Oh, what? It's got one of these at -3. -3 and 3. Really? You have 5 legs planted and you're doing something crazy like that. Okay. Can I actually copy it for real? No, of course I can't. Here's what I can do. I can just write this out. So I hate that it just actually doesn't copy. Why does it literally not copy? I gotta type them all out. Type them all out. 2614. -727. 828. 1705. 807. -878. 075. 807. 1767. Huh? Fuck. Do I really... Is that... Right. One count is supposed to be 5. So I'll just write. Because that's probably why it was... Why it just straight up didn't do anything. What the hell? 33 iterations, it got it down to 4. What? We're just not in the same universe? Just literally not in the same universe. Original length is 11,268. That's not... Huh? How are they getting different results? So I've just got them as... Alright, well, who's correct? I mean, that must be correct, right? It's just taking the length of each one of these vectors. Oh. It's because we're in the wrong coordinate system. Okay. Okay. All right. Three, 9, 7. Do you agree? You still don't agree. This is still... Wow. Huh? Okay. I mean, the results kind of look similar, though. The results do kind of look similar. But the original length is definitely wrong. Oh, no. That's not the same as the error. That's the original length. No. Okay. So what can you do after 10 iterations? Which I think is what I do here. What can you do with 10? Error 0.464. Huh? But the results... Alright, where are you going to put... Okay, where are you going to put this at? Let me move this down. It's being a little weird. Because I moved it down. It doesn't know what it's doing. Oh, apparently it does know what it's doing? How did you already run through the... You just didn't... Okay, now it's doing the iteration on this line, apparently. Okay. 3, 2, 5, 4, 4, 4, 2, 1, 8, 7, 2, 1, 9, 2, 5. I mean, those are basically the same values. Do I have like the error calculating wrong? I don't know how. Wait, am I even in the right place? Why is last error something like that? Last error is not -1 ever. This is just strange. I don't know what's... I'm supposed to be running the same code. It's really weird. The results are the same, but I'm getting somehow a different error readout between these two. This one tells me my last error is 0.21. This one tells me my last error is double that. I mean, okay. My ultimate goal here is to 1, negate gravity, and 2, minimize my angular velocity. So, minimize changes in my angular velocity. I had imagined that taking these vectors pointing to the legs, scaling them out, such that the sum of them all together is nearly 0, that would be enough. It seems to not be. Maybe I'm still like on a good track. Or maybe I'm not at all. Oh, was I looking at last results? 3, 4, 1. Okay, it is a little bit. No, I mean they're like actually just kind of really right on top of each other with the results. It looks like the same rounding. I don't know why the error is printing so much higher. Double. Because these should have run exactly the same calculations and got back the exact same result. This is a difference. Oh, no, that's not. That's 4959. 45959, which just rounds up to 46. So yeah, that one's. That Y is weird. I mean, I guess I could hover it and actually see. Yeah, that's more helpful. I don't like it. I don't like that I have a completely different error. After supposedly running the exact same calculations, I got nearly the same multipliers. They are all pretty close. 32027. 32027. 5426. That one's quite different. I would say that's pretty different. 44202. That one's kind of different too. So why is this different? How could it be different? Oh, I guess the last error is... Oh. Two 1629. Four 6 5. Okay. Okay, now they line up. Okay. Which means if I'm breaking the error being this, and that means it's before the square. So this is, it's still, that's still like, that is a huge error. That is a huge error. How long does it take? Yeah, okay. Run it as many times as you need. This one didn't get small until 30 runs. A 100 iterations, it never converged. How is this one that bad? It is lacking a positive x with a negative z. That is over 100 iterations. But it did get small at 29. So what is that 29th iteration? I could also just break early. But this is so many. It's too many to run. This is just too many. Adding 5 more brings it from 40. I mean, it's better, but I mean, it may be the case that I can ramp up slowly to like half after enough iterations. It's more just like the first couple translations I need to be careful. Because this one's doing what? It's 2/5. It's doing 0.4. Or, I mean, it could even ramp up to, like, doing by the full change. once it starts getting really accurate. Maybe we could base it on the error amount. I don't know. I mean, it's definitely the case where I'm getting insane errors. What did I had? I saw 19, but I know that's like technically it's not been squared yet. Or square rooted. That's still like a 4-meter error, which is insane to see. I mean, maybe what I could do is I could limit the midpoint to be, okay, the midpoint is essentially where that error is. It's essentially the full error distance. It is the current error distance, is what it's calculating. I think even like trending towards half the change is probably good. Or like 2/3. I mean, 2/3 is probably the highest I can go, right? So I could probably use something where as the size of midpoint gets small, I can allow more change. But how can I do that? I mean, really what I remember seeing is that what would happen is it would translate so much that after the rescale, it would like flip. It would basically cross the origin, I guess. Which means there's a point somewhere in there where in that slide, there's like an ideal amount to slide it by to get like suddenly really close. It's essentially when the error vector lines up with one of the existing vectors very closely. And you could essentially just slide if I go over a half, that's where I start running into it possibly flipping it over. It flips over. Maybe I could check when that happens. When the dot of the last midpoint is very similar and modify the multiplier. Maybe that is it. Okay. I'm gonna call there for today. Maybe I just need to also even like just totally reapproach it. Not completely reapproach it, but go at it with this concept, but more trying to pay specific attention to what angular velocity am I adding? What angular velocity would I add if I were to do this? which direction do I probably want to shift? I mean, I guess if I have angular velocity, then what I would do is I would say, all right, look at which direction I rotated, and if because I can look at which when I have each point, I could essentially do a test and say, all right, or not really do a test, but I can literally just run the calculation and say, okay, this leg is going to add like a degree of angular velocity this way. This leg is going to add a degree of angular velocity this way. And when I look at both of those, I say, okay, that's fine. They both cancel out. But maybe I say, this leg is added 1, this leg is added 1, this leg is added 1 that way. And now the total overall rotation is +1. So then I would say, all right, well, the positive ones need to go down, the negative one needs to go up. Right? Maybe that's what I should really look at. I should specifically check what angular velocity I'm adding and try to balance that out. I could even, I guess, approach it from here. Apply an impulse here. And... well, no, because they're all going to apply some rotation at the same time. Right? They're all going to do some kind of rotation at the same time. I can look at all of those results. Essentially, I encode at each point, it gets an angular rotation amount. And then that sum total needs to be reduced to 0. So those become the new vectors. And I say, all right, once I add all these up, those vectors need to reduce to 0. And then that becomes my multiplier. So then I say, all right, what was the angular velocity added? After the iteration, what's the new angular velocity added? And then that's what I should do with it. That'll be a multiplier. But what if one adds literally 0 angular velocity? I don't think it's possible. Unless the leg point is in the center of the body, that's not possible. Every leg is going to add angular velocity. I could do that. Okay. I think that's the real idea. I go to each leg, I do its shared mass, and I say, all right, now we have this. Let's bring it back to 0. And as long as there's 2 legs, and they're both pointing the same way, I think it is the case that it only really fails when there's 2 legs on the same side. Or all the legs are on the same side. There's not a single leg opposing any of them. Because then the total is doing this and like up or maybe even not. I mean, yeah. If it was like 3 legs on one side and it's mounted on the wall, it would do this. It would rotate this way and rotate this way. There'd be no leg on the other side to counteract it. But what is that shift? I guess the shift is just a multiplier. Is it the same thing? It might be the same thing. Because looking on this side would do like positive rotation, positive roll. Like on this side would do negative, or positive yaw, positive roll. Like on this side would do negative yaw, negative roll. Front legs would do positive pitch, back legs would do negative pitch. Maybe that's it. Maybe I just rework it so that it's the vectors we're dealing with are the angular velocities that each leg individually is applying at that moment. Okay. That's for tomorrow. Thanks for watching. Goodbye.